Well, howdy, welcome to Vintage Electronics Geek's Workbench, and today what we have is hopefully a repair video of this Hewlett-Packard 34401 Alpha. This is a multimeter. I picked this up a while ago at a ham swap, and I believe I paid $10 for it. It is marked with display in op, and that much I could very much guarantee you and confirm that yes, it is. We're going to take a peek at that, and with any luck maybe we will get to fix this, or we'll turn this into a basket of parts. So let's go ahead and turn this on and display. Show you that we have no display, that is. Alright, so we have the power on the Variac isolation transformer turned on. We'll go ahead and turn this on, and I believe we're going to get a beep or two. I think we need 2 beeps for it to boot up properly. Alright, there's our 2 chirps. Not necessarily beeps, they were chirps. And as you see, there is nothing on the display. Let's go ahead and stick some probes in. Now, during my testing, what I found was that I believe that this device does work. And even though we can't see it, we're going to do a very basic test to confirm that. So it appears to work. The display on this, if you were to find a OEM HP Agilent display, is really expensive. Next best thing, aftermarket, China. I have since ordered a new one aftermarket. Now, there is a fella that does repair these if you don't want to try goofing yours up. You'll find him on eBay. I originally thought about doing that my own self because I don't have the proper tools to do this. But I thought, well, it's probably not going to make a very good YouTube video. Have somebody else repair it. Guess I could send my camera team in, and so we're going to attempt to do this. One of the other problems that I could have is the display driver is bad in this. They made 2 types of boards. One, easy access to the display driver to test while it's in line, and the other, not. And this one is in the not category. The the fluorescent display is right over top of the driver, and you just can't get to it. So I was unable to test that. We're going to go ahead and turn this off, and we're going to crack this open. I'm going to do that off screen. Well, I can crack it open on screen, but as I'm talking. But to remove the board out, that one I'll probably do off screen. The way how it's done is this really weird latching system to remove the board. Bump you out a little bit there. Another complaint with these devices are we've got some electrolytic in here that do give out and tend to leak and cause problems. So for preventative maintenance, I'm going to go ahead and replace those, providing we can get the display to function. And here is this weird, goofy, torturous mechanism that it's not fun to deal with. And what's neato is they gave you two of them. I mean, it's kind of easy, neat, but also a pain. So these are the capacitors that you can't see. Alright, so here are the capacitors that we will be changing, providing I can get this thing to fire up. So I will try to tear this head off real quick on camera, but if this don't work, then I'll turn the camera off and let me change camera angle so you can see better. Alright, so hopefully here we could see a little bit easier, or you could see a little bit easier. I'm going to pull this power button out of the way, I think. And let's see if I could get this pulled up. Well, no matter what I do, my hand's in your way and in mine. You got these, can't see them, but there's some screw studs right up in here. Oh, right there. There. That we got to squish the case together, and then this hopefully will pop out, and we got to get past those. And that's why I wasn't going to do this on film. But I figured, well, you've probably never seen this done, maybe. Man. Okay. Got it ripped off. Now, next thing we need to do is we got to remove this ribbon cable and then this jumper back here. Let me remove this plate. This I have a little bit more finger room. And then the first time I removed this cable, it was okay to pull out. It was horrible to put back in. And then I found out there's a trick with this kind of a connector. You just simply push down on it. And by doing that, that opens this up just enough to get those contacts in there. I fought with that for a little bit until I figured that out. Alright, so you can see we have it decapitated. And that's interesting, right? There is a date of January 28, 1998 right here. And that's what she looks like underneath. Alright, let's move that out of the way. And here is the head. Now there is a secret way of, special trick or whatever you want to call it, to remove that out of there. And you'll take note that there's no screws. What was that special trick? I think we just slid. I think we push. Take. And get you in frame so you could see. Alright, so you take this tab right here and pry it up and then slide that over. I know you didn't see because my hand was in the way, but once you pry that up, just slide the board over and then pull it right up. And there we go. And there is our display. And right up in there, in the center about where my thumb is where our device driver is. And you can see it's SMD, and this here is just the pins for the ribbon cable. So no way to probe it from this side. As I stated in my preamble, I don't have the necessary tools to remove this. You know, a nice solder sucker would be awesome. So, until one of you fine folks or businesses would like to donate old VEG, a really awesome solder gun, I'm going to have to do this old-fashioned way. But hey, if you donated one to the channel, let me tell you what, I'll be your best bud for about 10-15 minutes tops. I guarantee that. Anyway, so let me go ahead and pause the camera here. Let me get set up. or actually, let me rephrase that. I'm not going to do this on camera. As you see, little tiny things, and fight to get it out. What I may end up doing if I cannot pull it out successfully the old-fashioned way, I'll just come in with some snips and I'll cut the leads here. As you can see, cut these leads here, plop it off, and then come in with the iron, heat up, and then pull each one of the pins out and clean the hole up, stab it into place. So let me do that, and I will jump in when I'm done and we are ready to test. Okay, just wrapped up getting this all soldered into place. Here's the new display, complete with reflection. Looks really good. Now I'm going to throw up some pictures, and here you're going to see what it looks like underneath the display. And then the next couple of shots are of the components themselves. I would imagine they're going to be the drivers. I didn't take enough time nor care to punch them up to see exactly that's what they are, but I'm pretty confident that's what they are. I did not do any testing on them. Okay, well, fantastic. Let's go ahead and put this into place, and then we will test it. Now, before I do so, let me just give a big shout out and thank you to the wife. Apparently my lips and tongue are not functioning, talking to one another. Past couple of days, my eyeballs have been really tired and hurting. And so taking this project on, maybe I should have waited a few days, but either way, here nor there, I invited the missus to come in and save the day again, and that's exactly what she did. She did an awesome job getting the legs removed out of there. There's really no issues doing that. We did it old school way, and came right out. First time for her, and jazzed. So let's go ahead and let me clean this up real quick, and we'll bring over the machine. We'll plug it in, and we'll test it. Won't even install it. We'll just plug in the wires, and then we'll test it. All right, got it stabbed into place temporarily. As you can see, I'm using some really nice ANSI and Cal OSHA approved safety protection there. Don't try that at home unless you're a professional like me. RR. Got it plugged in, stabbed in. Let's go ahead and see what happens. I'm going to go ahead and throw the switch on the isolation variac. Device is turned off. It should be. And now we're going to hit the power switch. Holy smokes, there we go. How awesome. Yay. Very cool. Is that awesome or what? And that is really nice. Let's see what it looks like. Yeah, that's going to be awesome. Amazing. Yeah, my $60 tool right there. What a good investment that is. Awesome. All right. Well, the wife, and I are very jazzed. So the next thing is to address the capacitors. The reason we're addressing those is, I guess, they are a problematic issue, and they do leak, and they will eat the board. So I'm just going to do preventive maintenance and take care of it now while I can before I stab it in place or before it goes goofy. So let me kill this, and I will see about looking at the capacitors. I want to pull them out and see if I have them in stock. If I do, then we'll carry on. If not, then we'll pause until I get the parts in, and then we'll pick it up from there. And we'll also do a self-calibration on the machine. All right, I'm back, and great news. I had all the capacitors in stock, on hand, raring to go. So we've replaced this one, and then we've replaced these three right here. I would like to, again, give another shout out to the wife. She went ahead and changed those out for me. I was getting ready to do them, and you know, she's interested in this stuff as well, so I went ahead and offered it to her, and sure, why not? So how awesome is that, right? And the capacitors in question that were pulled were these that you can't see. There we go. Move them over there. Would have thought you'd have so much difficulty trying to set 4 little capacitors down. Well, that's what happened to me. Anyway, got those pulled out, checked them on the Syncor LC75 capacitor meter, and their values were pretty much spot on. The ESR, they all showed high, and leakage didn't show any real leakage. So it's very plausible that, yeah, this device has been sitting for quite some time in a unplugged status, and the only time it's been turned on is what you've seen on camera during this video. So it's very plausible that, yes, they have not had a proper chance to reform, and I'll give them that. I'll check them out later. I'll test them, put them on the power supply, let them cook for a while, and retest and see what happens. Now, the next thing for us to do is let's go ahead and check this little guy out, see if we get anything to blow up or if we get any life to come out of it. So I just checked the power switch. It's in the off position. Let me turn on the variac isolation transformer. And I do believe my microphone always picks up that buzz when it kicks in. So this is rejuvenated. Let me kill my light. That way we could see the display here a little bit easier. And if something was to explode here, I'm sure the rest of the lighting will catch it. So let's fire it up and see what happens. Awesome. Now let's go ahead and punch some buttons. Oh wait, I got no buttons. Alright, so what I'm going to do next is I'm going to put the machine back together. And I think I'm going to wipe down the inside of the display just to make sure any dust is off of that. I'll put it together, then we'll come back. Maybe I'll take some probes and touch them together just to make sure it does work something. And then we'll run the self-diagnostic, self-test on this, or the self-calibration, and let it set itself up. To save time and not do a bunch of little clips, since we see that the device does work, what I'll do is after I assemble it, is I'm going to leave it powered on for about a half an hour, and then we'll come back, and then that's when we'll do the self-calibration. That way it has a chance to warm up, let the tubes do what they need to do, the capacitors do what they need to do, and yeah, I know I said tubes, I was just being funny. So let's do that. Hey, check this out. Last clip so we'll put it together and we will check it out, and we'll even run the calibration test. Well, the calibration test, I might have been thinking of something totally completely different. It may not be the calibration menu that I was thinking of. It actually might just be a diagnostic menu. We'll figure this out as we go, exactly what it is Jack is trying to say. Secondly, the audio on this video on this portion of the video may sound a little different. The last clip was shot about 5 days ago, and I forgot to turn my microphone off, and the battery ran flat. So I don't have a replacement battery, and until I can get one, we're just going to use the microphones on the audio recorder, so hopefully it ain't too bad. And since I keep it in my pocket, hopefully there's not a lot of scuffing noise as I move about the cabin flaying about. Secondly, I did assemble the device and started cleaning the cabinet. I cleaned the face up and it looks really, really nice. And I powered it on to test it, to look at it. That is when the problems began. And that is why I have it tore apart again. So let's go ahead and take a peek at what's happening. So I'm going to hit the big red switch to the ISO Variac. Keep your eyes on this section right here. And here we go. Look at that. Ain't that awesome? I broke it. I broke it real well. I could emulate that. Anyway, sorry about that. The phone was ringing, so I had to take care of that. Anyway, as I was saying, I can emulate the problem. And over again, I could emulate that. So what I've done so far was I've checked the voltages here on the cable, and it appears that the cable is getting the correct voltages. After spending gobs amount of time on the internet researching this, I see that this is a issue that a lot of folks have also ran into. And through all that research, what has told me... Alright, so a couple of things here. I need to come into this area here and check the voltages up in here. This section has a floating ground, and so I need to take this board out of the chassis and come in and solder in some flying leads up in here so I could properly test this section for voltage. I need to come back up in here and check some more voltages, make sure it's been, like I said, several days since I've last dorked with this, but I think it's a 5 volt and 12 volt or something like that rail. Might even be a negative voltage. Anyway, I'll pull the service manual back up and we'll look, see what I need to do, and I'll check for my voltages up in here. One thing that a lot of people have stated with this issue is that this component right here gets zapped somehow and goes bad. So I think that's also part of the voltages that I got to check to see if I'm getting proper voltage to it. And if I am, then I will probably have to remove that and put a new one on. Another thought I've had was to pull these capacitors back out. Oops, that's not a cap, that's a fuse. Pull these caps back out, put the old ones in, and see what happens. The device was working just fine up until that point. However, we are right next to it, so it's very plausible that static electricity had happened, and we inadvertently blew that. And here's a tighter shot of the component in question. What I believe that was is memory. The CPU's here right to it, and then if it feels like it, it'll write back. It just depends on if it's got a headache or what kind of mood it's in. So that's the heebie-jeebies on that. If I determine that is the problem, or my voltages are fine, either way, I'll probably order this part, and we'll put that in. That'll probably take several days for that to roll in. So if that's the case, we won't see a second part of this video series until I get that back in. Anyway, just wanted to report back to you and let you know what was happening and why we don't have a fat and happy end result in this video. Unfortunately, it will become a part 2. So until then, we will catch you in that one, and I'll give you my report on what I found or what the resolve was, or something cool and exciting. Catch you in the next video. Thanks for watching. As always, I do appreciate it, and we'll see you then.